Okay, thank you. So, I don't know, that's the last one for today here? Yeah, oh, okay, so we have more. Good, good, good. So there's more to go. So, this presentation will talk about the the challenges that analog designers, okay, are facing today with the advanced nodes, and how Cadence helped them to resolve these challenges. So, my name is Amir Bar-Niv, and I'm running the marketing of the Design IP group in Cadence. And we will talk today on all the IPs that Cadence introduced into the market in those advanced nodes. So let's start with the fact that the number of IPs, the average number of IPs on a typical SoC is growing, again, growing dramatically when people are moving to advanced nodes. So this is an interesting graph from IBS that shows that in 40 nanometer, people used to have about 70 IPs on an average SoC. In 14 and 16 nanometer, now it's over 120 different IPs, okay? So there is different level of challenges also to integrate all those IPs together. The other part, the biggest challenge for the designers, both the IP and also the companies that design those analog circuits, is that design of analog circuits start to be much harder when you go to advanced node. Okay, much harder. I will talk on some of those challenges, and then I will explain how Cadence help the SoC community to resolve those challenges. So let's start with what we call, we like to call it the vicious circle. Okay, we start with the economical justification. To do a tape out, okay, in advanced nodes, 16 FinFET, 14 FinFET, it's very expensive. Okay, as most of you know, it's many millions of dollars. These are the advanced nodes that exist today out there. Also, the wafers, of course, are much more expensive than standard wafer in the legacy nodes. So if we look on this, the digital is shrinking, so Moore laws still apply for the digital part. Okay, you can see that the average dollar per transistor is continue to go down. But this is true for the digital. For the analog is not shrinking as much as the digital. Okay, so on most of those design, when you have a lot of analog, then you see that the average transistor, the dollar per transistor, okay, it's flat or maybe even going higher. So these processes are more expensive. Now, in order to justify the use of these processes, then people that design these process nodes, the advanced process nodes, use the most advanced circuits, okay, in the industry, the highest bandwidths, okay, the highest switches, router, application processor, really to justify and get the full benefit of the horsepower of these advanced nodes, okay. So in those design, we are really going to the highest speed exist for the highest protocol that exists in this current application. Now, analog design is very challenging in those advanced nodes for many reasons. But when we are pushing also the envelope of performance, okay, going to the PCI Gen 4 16 gig or very high-speed services, then this is only amplified those issues that we see today in analog. So what are those issues? The issues also, first of all, related to matching. Okay, as you know, the matching is proportional to the inverse of the size of the transistor. So the smaller the size, the worse the matching, and the more bigger issues that company sees in those devices that design in those advanced nodes. Power dissipation is another big problem. The transistors are extremely small and they cannot dissipate all the power. And then also the voltage dynamic range. All these challenges means that the design cycle of analog increased on average by about 150% over the legacy nodes. Now, the issues of matching, mainly the matching, requires a new methodology for design of this analog design, and this is called calibration circuits. Almost every analog circuit in those advanced nodes needs to have some type of calibration. Otherwise, the parameters are all over the range, when temperature change, when voltage change, and when the different process and the different corners of the process. So calibration circuits are a must, okay? This is a new methodologies that been developed by companies in order to support this challenge, which also increase the complexity of the design. Those calibration circuits, we don't turn them on all the time, okay, because it consumes a lot of power. So we turn them every 100 cycle, every 1000 cycle, okay, in order to reduce the power. And then we are going to the biggest challenge of this design, which is the verification. First of all, when you are tapping out a design that costs so much money, okay, you better verify everything, okay, again and again and again to make sure you don't need to respin the silicon. So people spending a lot of time on verification. The calibration circuit add more complexity because if now the calibration circuit is turned on only every 1000 clock cycle, you need to run the verification for a long time in order to see the impact of the calibration on the circuits, on the analog circuits. So verification starts to be a very long and tedious process, okay? Again, on average, the verification is about 2 to 3 times longer than what it used to be in legacy nodes, which add again to the complexity and to the cost of designing in advanced nodes. And that takes us back to the economical justification of designing in advanced nodes. Now, the good news is that Cadence is doing designs in advanced nodes for 3 or 4 years by now. So we were able to resolve all those challenges, develop all those circuits, and we are providing these IPs to our customers that can integrate it in their SoC. One of the unique approach that Cadence took is leverage. What does it mean? Instead of designing, for example, we have 6 different protocols on an average SoC like USB, PCIe, Ethernet. Instead of designing the different PHY for each one, then Cadence is using what's called multiprotocol PHY. A single PHY that can work in many different protocols. So for example, here we have a multi-protocol PHY in process X. So once we ported it to a specific process and specific flavors, then immediately in that case we are getting 6 different products, okay? In this case it's the USB, it's the PCIe, the M-PHY, DP and EDP, SATA and SGMII and QSGMII. By simply integrate, okay, the controllers that are soft IP, so they can work in any process node, the controller from Cadence with this PHY, and then immediately you get 6 different products, okay, by porting of one PHY, okay? So we don't need to repeat again and again this tedious and very hard process of creating a new PHY. Now, Cadence took this approach beyond the SerDes technology. Today, we are using multiple PHY also for DDR and LPDDR for our memories, and we also took this approach to our analog front end, okay, the analog mixed signal designs that we have. Of course, the biggest challenge is with the overhead. You want to make sure you don't want a big PHY, you know, that can meet all, they can use for all these protocol. You want it to be very optimized and both on size and the power. So the size of our multi-protocol PHY is less than 10% of any of the other PHY of any that exist for this protocol, and the power is fully optimized for each of the specific protocol. The same goes for the other digital layer, like the PCS, the physical coding sublayer, that we make sure it can support all these protocol, but once a customer decide which protocol they want to use, let's say they want to use just USB and PCIe, then the PCS is adaptive and it can use the circuits and the gates that only needed for these specific protocols. And then we are giving to customers with this multi-protocol IP the full system, the full solution that goes with the verification IP, the subsystems that is part of it, the software, and then the signal integrity design kit. So the advantage for the customer are pretty obvious. It's one SerDes, so one PHY that they need to integrate, okay? They don't need to integrate multiple PHY into the same design because it's the same PHY. They just need to instantiate it a few times and connect with different controllers. It's one PHY to characterize instead of characterize multiple PHYs. The interoperability is already tested with all the controllers before we deliver it to the customer, so customers have no issues of interoperability of controller and PHY. Register set is pretty much the same, so the drivers are the same, and of course it reduced the license cost. Instead of licensing, 6 different PHYs, you can license one PHY and then instantiate it multiple times. Of course, there is also advantage for the foundry because it needs to be one PHY for porting. When you have PDK update, and you need to do it only once, reduce the number of shuttle testing, and of course reduce the yield risk because it's only one PHY that need to be fully qualified, and it's a single source for the vendors, for the foundry vendors that can give them all these protocols. So this slide is pretty much showing, in more details what I just described. So when you have a single protocol service versus multi-protocol service, then the porting you need to do only once versus 6 times, the characterization, the integration, qualification like HTOL, HAP, and ESD need to be done only once, and of course PDK update, you need to do it only once there is a new PDK available from the fab. So this is an example of our first multi-protocol 16 gig SerDes. Okay, you can see that this PHY and SerDes support 16 different protocols, starting with PCIe, Gen 1, Gen 2, 3, and 4, USB 3 and USB 3.1, 10 GKR, and then a bunch of other Ethernet protocols. For the 6 gig SerDes, this is our mobile SerDes, okay? We wanted to squeeze the size, okay, to make it very optimal for mobile application. So we reduced the number of protocols. So this one can support this protocol like PCIe, USB, SGMII, DisplayPort, and the M-PHY. And then we continue this approach also for our DDR PHY. So we introduced last year the first PHY in the market that can support both DDR and LPDDR 3 and 4. And there is a real need for that in the market. The reason is that, as you know, LPDDR is the lowest power solution in the market and used in the mobile, and can also drive much higher speed than DDR. It can go today to 4266. On the other hand, LPDDR is today much more expensive than LPDDR is much more expensive than DDR, because for every one LPDDR that you sell in the market, you sell 100 of DDR memories. But the volume of LPDDR is growing and the price are decreasing. So today, customer can license our multi-protocol DDR and use it with DDR, which is cheaper. And in a year, when LPDDR prices will go down, they can switch to LPDDR. They don't need to retape out the chip, and they can use the same chip with LPDDR. Okay, so this is the main use for our multi-protocol DDR and LPDDR. And then we continue with this approach also for our analog front ends. Okay, the mixed signal and analog front ends. So this is the example of the wireless analog front end. You can see that it can support all these protocols, starting with Wi-Fi, mobile, broadcast interfaces that are more common in China, and then the narrowband wireless like Bluetooth and Zigbee. Okay, so let's see also which market coverage, okay, which market segment we can cover with these multi-protocols. So the 6 gig SerDes can today cover application in mobile and consumer, and the 16 gig SerDes, the LPDDR, DDR, and the analog front end basically can cover mobile, consumer, and infrastructure type of application, because it can support all these protocols. So Cadence today basically have the full portfolio, okay, of IPs, starting with memory, the DDR, LPDDR, storage and NAND, and also the special memory like HBM and HMC. We have all the wired interfaces today available to customers in production, like display, MIPI. We have all the controllers like SoundWire, CSI, DSI, and also the D-PHY and the M-PHY, Gear 1, 2, and 3, and now we are doing 4. USB, we have all the different generation from USB 2 up to USB 3.1, PHY and controller. On the controller we have the host, the device, the OTG, the dual role. And then PCIe, we talked about it, we have all the generation. And Ethernet, we have MAC anywhere from 10 meg up to 100 gig. We have the gigabit PHY, which is a unique IP, 1000 base T, that is available today. And also the other type of Ethernet PHYs. And on the analog and mixed signal, we have today more than 250 different IPs in different processes and flavors like A to Ds, DAC, PLLs, etc. The sweet spot is 28. We have 28 and 16, so we have all those IPs ready in 28 and 16, and now we are moving also to more advanced nodes with all these IPs. Okay, so just to summarize, so today Cadence have a complete portfolio, okay, that includes memory, storage, interface, and analog IPs. We are providing to customers the complete solution, the multi-protocol files, subsystems, and also integrated with Cadence tools already. And then we are continue to invest and expand. Today, Cadence is the fastest growing IP company in the market. Okay, any questions?
Amir, what customers that you can talk about are using your IP today? Which customer?
Well, I cannot mention too many customers' names because we are under NDA. I can mention those that we had press releases with them. Okay, so for example, companies like HiSilicon that are using our DDR in mass production. Okay, I cannot think. I can mention a few other companies. I prefer not to get into it. Okay. But our products today are being used by most of the tier 1 companies. Okay, I would say 90% of the product that I showed are already in production in those advanced node 28 and 16 FinFET.
Okay, all right. Any other questions? All right. And how much of the portfolio is available today?
Well, the full portfolio that I showed, everything is available. Okay. Everything is silicon proven. Okay. Right. Again, it's different level of maturity. We have it in. We have also in legacy nodes like 65, 40. But all of it is in 28 and 16, and now we are going also to more advanced nodes.
Perfect. Thank you so much, ladies and gentlemen. Amir Bar-Niv from Cadence DIP. Stick around. We're going to give you some blue tickets, because we have a drawing at 5:30 at our 5:30 presentation. I believe right after that, and that's for an iPad Mini. So thank you so much for joining us today.